Hello, I'm Mel Gomez. I'm a professor of electrical and computer engineering at the University of Maryland, College Park. And I also serve as the director of the Cyber Physical Systems Engineering undergraduate program. I wish to tell you about the CPSE program and why it could be a good choice for an engineering student. The program was created under the State of Maryland's Workforce Development Initiative about 6 years ago, with the objective of developing skilled industry-ready workforce to meet the demands of rapid changes in our technological landscape. The field of cyber-physical systems is the driving force in today's data-driven society. And our program of study is structured to empower our students to have meaningful careers and thrive in this environment. Let me clarify what cyber-physical systems engineering is all about. The term cyber-physical systems was first introduced in the early 2000s by Dr. Helen Gill of the National Science Foundation to describe a research area in which computation and physical processes are connected. The field is highly interdisciplinary, combining the traditional fields of electrical engineering, computer science, and computer engineering. Cyber-physical systems encompass topics in embedded systems or specialized computers coupled with mechanical devices, control theory, the Internet of Things, and data analysis. A few well-known applications are the driver-assisted or driverless car technologies, smart transportation systems, smart cities, healthcare, industrial automation, efficient energy management, smart wearables, and of course, gaming. A particular example as we look into the future is our society's reliance on artificial intelligence. AI, of course, depends upon trustworthy data, and cyber-physical systems enable us to use a network of sophisticated measurement tools and communication protocols to establish the ground truth data for AI. We anticipate that with continued advances in computing hardware, data storage, communications and networks, applications of cyber-physical systems will only proliferate even more across our society in the coming years. The CPSE undergraduate degree is a 2-year program offered by the ECE department at the University of Maryland, College Park. It accepts transfer students who have completed their general education requirements from the University of Maryland or any other 4-year institution, or students who have obtained an Associates of Science degree from a community college. Included in this group are the dual-enrolled students who receive high school diploma concurrently with an associate's degree. The program is fully ABET-accredited. ABET is the national accreditation body for engineering studies, and this program is the first accredited program in the area of cyber-physical systems engineering. Students in the program earn their undergraduate engineering degree from the Clark School of Engineering and receive their diplomas at the same time as students from College Park. Our CPSE program is an undergraduate degree. And as an undergraduate program, it aims to offer a broad understanding of the technologies involved in the ecosystem of devices and algorithms to be able to develop the skills to design, maintain, and innovate gadgets and systems in our data-driven society. To put it in context, let us compare the CPSE program with the more traditional degrees of computer science and computer engineering. Here's a Venn diagram that compares the three. We begin with computer science. Computer science is focused on software and algorithms. The core topics include coding, discrete structures, algorithms, and computer architecture, which are complemented by theoretical concepts on information theory and programming languages, networks, and cloud computing. Computer engineering shares the same foundations of computer science, but now it's more focused on hardware systems. The curriculum includes analog and digital circuits, microprocessors, and elements of embedded systems. The cyber-physical systems engineering encompasses the fundamental concepts of both computer science and computer engineering disciplines. In the CPSE curriculum, students learn the foundational engineering principles common to electrical and computer engineering, foundational principles of analog circuits and digital logic circuits, foundational principles of networks and communications, foundational principles of quantitative probability and linear algebra, foundational principles of the Internet of Things, foundational principles of computer operating systems, including real-time operating systems. Additionally, students learn industry-relevant topics such as how to build systems on chip, full-stack development, hardware security, and web-based deployable applications and machine learning applications. In short, our students learn a broad picture of the ecosystem from the level of transistors and gates and building blocks to advances in microprocessors, hardware and software co-design, and most importantly, real-world applications. A highly qualified teaching staff teaches our courses. We currently have 8 faculty members teaching the courses. 4 are professors from ECE at College Park. We have 1 senior lecturer and 3 affiliates. All have PhD degrees in the areas they teach. The instructors are assisted by a group of graduate students who serve as their teaching assistants. The CPSE program has excellent laboratory facilities in the recently built Biosciences and Engineering building at the university's at Shady Grove campus in Rockville. There are 2 dedicated laboratories that you will see in the tour section. Let me summarize what I mentioned earlier. The CPSE program shares the same DNA as the ECE department at College Park. It grounds the student in strong engineering foundations. The curriculum is very rigorous and coherent, designed to help graduates enter the workforce and thrive.